What if every experience you've ever had, every touch, every emotion, every breathtaking sunset wasn't real? Not in the way we think, at least. Scientists and philosophers are locked in a debate that sounds straight out of a sci-fi thriller. The unsettling possibility that our entire universe might be an intricate simulation running on some cosmic supercomputer. And here's the catch: there's mounting evidence that makes this theory harder to dismiss than you'd expect. Today, we're unraveling 18 mind-bending clues that blur the line between reality and illusion. From eerie mathematical patterns in nature to unexplainable cosmic glitches, these aren't just wild guesses, they're legitimate puzzles that even experts can't fully explain. If even one of these ideas is true, it would mean everything you know isn't what it seems, ready to have your perception of existence turned inside out. Let's begin. Picture the world around you. Everything seems seamless, continuous, perfectly smooth. But what if, like a high-definition screen, reality has a hidden pixelation we just can't perceive with our eyes? Scientists probing the deepest layers of existence have found something bizarre. Space-time itself might have a resolution limit at the unimaginably small Planck scale, where distances shrink to a trillionth of a millimeter. The fabric of the universe stops behaving like a flowing river and starts acting more like a series of tiny, indivisible grains. It's as if nature has a minimum zoom level beyond which you can't see finer details. This discovery sends chills down the spine because it mirrors how digital simulations work. Think of a video game. No matter how lifelike the graphics appear, they're ultimately built on pixels, tiny blocks of data. Movement that seems fluid is actually a rapid flickering between fixed points. If our universe operates the same way, it raises a haunting question. Are the pixels of reality proof of a cosmic designer, meticulously coding existence frame by frame? Even empty space, once thought to be perfectly smooth, might be quantized, built from minuscule, discrete units. The deeper we look, the more the illusion of continuity cracks apart. Some physicists argue this granularity is just how nature works, no simulation required. But others see it as one of the most compelling hints that reality might not be what it seems. After all, if the universe were a simulation, wouldn't it need some kind of underlying code, a fundamental grid to process information? The Planck length could be that grid, the universe's hidden resolution setting. Whether you find this idea electrifying or unsettling, one thing's undeniable: the closer we examine reality, the more it looks constructed. Now, let's take a detour from the quantum fabric of reality and step into something far more personal: our memories. How certain are you about the details of your own past? What if thousands of people shared the exact same wrong memory, swearing events unfolded differently than history records? This bizarre quirk of collective consciousness is known as the Mandela Effect. Take the classic children's book series, The Berenstain Bears. Millions insist the name was once spelled Berenstein with an E. Yet, every official record shows it was always Berenstain. Or consider movie quotes ingrained in pop culture. Darth Vader never actually says, "Luke, I am your father." The real line is, "No, I am your father." So why do so many misremember it identically? Some researchers wave this off as simple cognitive distortions, our brains filling gaps with familiar patterns. But simulation theorists raise a wilder possibility. What if these aren't just memory glitches but literal overwrites? In a digital universe, files get corrupted, updates alter code, and patches change parameters. Could the Mandela Effect be evidence of reality itself being edited, leaving traces in our recollections? It's not just about spelling or movie lines. Some recall entire events differently, like Nelson Mandela dying in prison in the 1980s, hence the phenomenon's name, despite him living until 2013. If reality were a simulation, inconsistencies might emerge from version changes, like a cosmic developer tweaking the program. Of course, psychologists argue shared false memories stem from social reinforcement and faulty neural wiring. But when so many people independently recall the same false details with eerie consistency, it forces us to wonder, is this just how human brains work, or could it be something far stranger? Here's the next segment of the script. At the smallest scales of existence, the universe plays by rules so strange they seem almost programmed. Take the quantum world, where particles don't behave like tiny billiard balls but more like ghostly probabilities. Until you measure them, they exist in a haze of all possible states at once, like a character in a video game that only fully loads when you turn the corner. This isn't science fiction, it's the bedrock of quantum mechanics, and it raises a startling question. Could this indeterminacy be a sign that reality is buffering? The famous double-slit experiment lays it bare. Shoot particles like electrons at a barrier with two slits, and they don't just pass through one or the other, they act like waves, interfering with themselves as if they'd traveled both paths simultaneously. But the moment you place a detector to observe which slit they take, the particles suddenly choose a single path. It's as if the universe is saying, no need to render the details until someone's watching. Simulation theorists see this as a potential optimization tactic. Think about it. A game engine doesn't render every leaf in a forest or every brick in a distant building. It saves processing power by only generating what the player sees. If our reality works the same way, quantum indeterminacy could be the universe's way of cutting corners, avoiding the computational heavy lifting until absolutely necessary. Even Nobel laureate Eugene Wigner toyed with the idea that consciousness itself might force reality to collapse into a definite state, an eerie echo of a simulated world responding to its observers. Critics argue this is just how quantum physics operates, with no hidden programmer required. Yet the parallels are hard to ignore. After all, if you were building a universe-sized simulation, wouldn't you prioritize efficiency too? Whether it's a fundamental quirk of nature or a backdoor in the code, one thing's certain. The quantum world refuses to play by the rules we expect, and that's exactly what makes it so compelling. This segment maintains flow from the previous ideas while introducing fresh angles, avoids repetition, and balances accessibility with depth. Let me know if you'd like any refinements. The universe hums with numbers, not just any numbers, but impossibly precise equations that govern everything from the spiral of a galaxy to the flutter of a hummingbird's wings. Take the Fibonacci sequence, a simple pattern where each number is the sum of the two before it: 0, 1, 1, 2, 3, 5. Yet this same sequence appears in sunflower seeds, hurricanes, even the shape of our own DNA. It's as if nature follows an invisible recipe written in a language we're only beginning to decode. Elon Musk isn't the only one who finds this suspicious. He once quipped that the chance we're living in base reality is 1 in billions, precisely because the universe feels too mathematically tidy. Think about it: gravity, light, even the nuclear forces that hold atoms together. All obey razor-sharp laws that can be scribbled on a napkin, yet predict cosmic events billions of light years away. It's eerie, like stumbling upon a perfectly crafted clock in the middle of a wilderness and realizing it's keeping perfect time. Simulation theorists see this as a smoking gun. After all, what's the most efficient way to build a universe? Not with clunky, arbitrary rules, but with clean, universal algorithms, exactly like a programmer designing a virtual world. The gravitational constant, a fixed variable in the code. The speed of light, a hard-coded limit to prevent system overload. Even chaos has its own equations, as if the simulation allows for randomness within a controlled framework. But here's the twist. Some mathematicians argue this perfection doesn't require a programmer. Maybe math isn't invented by the universe, but discovered a fundamental truth waiting to be unearthed like buried treasure. Einstein called it the incomprehensible comprehensibility of reality. The fact that the universe not only follows rules, but that our minds can understand them at all. Whether you see math as divine blueprint, cosmic coincidence, or literal source code, one thing's undeniable. The deeper we dig, the more the universe looks like an intricate equation solving itself in real time. And that leaves us with a haunting thought. If reality is coded, who or what wrote the program? The sky has always been humanity's grandest mystery, but what if some of its strangest visitors aren't from distant galaxies, but signs of something far more unsettling? For decades, military pilots, astronauts, and ordinary bystanders have reported objects in the air that defy every law of physics we know. Sudden 90-degree turns at hypersonic speeds. Hovering silently without wings, rotors, or exhaust, vanishing in the blink of an eye as if someone hit delete on reality itself. These aren't just blurry camera tricks. The U.S. government's own declassified footage shows crafts performing maneuvers that would liquefy human pilots and shred conventional aircraft. Physics says these things shouldn't be possible, yet there they are, darting through our skies with impossible agility. Simulation theorists see these UFOs, or UAP, unidentified aerial phenomena, through a chilling lens. Could they be the equivalent of debugging tools in a universe-sized program? Think of a video game glitch, an NPC non-player character suddenly teleporting or a texture failing to load. Now imagine that on a cosmic scale. Witnesses describe crafts splitting into multiple objects, changing shape mid-flight, or even passing through solid matter. If reality were a simulation, these could be artifacts of rendering errors or something far more intentional. Perhaps these phenomena are admin avatars, entities monitoring or even maintaining the system, oblivious to the stunned humans below. Skeptics argue these sightings have prosaic explanations: experimental military tech, atmospheric anomalies, or simple misidentification. But when trained fighter pilots, people whose careers depend on identifying aircraft, report encounters that leave even radar systems baffled, it's harder to dismiss. The Pentagon's former head of UFO research, Luis Elizondo, once admitted some objects exhibited characteristics that challenge our understanding of aerodynamics. Whether these are secret government projects, extraterrestrial visitors, or something stranger like digital artifacts bleeding through the code of reality, one thing's clear: the more we investigate, the more the skies seem less like empty space and more like a canvas where the rules can be rewritten at any moment. And if UFOs are glitches, what does that say about the stability of the world around us? There's that uncanny moment walking into a room, hearing a stranger's laugh, watching sunlight hit a coffee cup, when suddenly you've been here before. Not just the place, but this exact second, down to the goosebumps on your skin. Déjà vu is more than a fleeting oddity. It's a glitch so universal, nearly 2/3 of humans report experiencing it. But what if this isn't just your brain misfiring? Simulation theorists suggest something far wilder. Déjà vu could be reality itself stuttering. Picture a video game freezing for a split second, then replaying the last few frames to catch up. Now imagine the universe doing the same, repeating a fragment of time to smooth over an error, like a cosmic Control plus Z. If our reality runs on computational rules, déjà vu might be the equivalent of a buffer reload, a tiny reset to keep the simulation seamless. After all, even the most advanced systems need patches. Maybe these moments are when we notice the edit. Neuroscientists have their own take, of course. Some argue déjà vu is just a brief mix-up in memory processing, where the brain mistakenly labels the present as a past experience. But simulation proponents counter. Why would evolution hardwire such a specific glitch? And why do so many describe it with identical details, a visceral certainty, like déjà vu isn't just a feeling, but a memory of a moment that never happened? Here's where it gets eerier. Studies show déjà vu often spikes during stress or fatigue times when a system might be most prone to errors. And in rare cases, epileptic patients experience prolonged déjà vu, as if trapped in a loop for minutes. Could these be extreme examples of the simulation struggling to sync? Whether it's a neural quirk or a backdoor in reality's code, one thing's certain. Déjà vu pulls back the curtain on how fragile our perception of time might be. The next time you feel that phantom familiarity, ask yourself, did your brain misfire or did the universe just rewind? The cosmos stretches across 93 billion light-years, brimming with trillions of galaxies, each home to countless planets. Given those staggering numbers, the universe should be buzzing with alien megastructures, interstellar chatter, or at least the occasional cosmic greeting card. Yet when we listen, all we hear is silence. This glaring contradiction is the Fermi Paradox, and it gnaws at one of science's biggest assumptions. If life is common, where is everybody? Some argue intelligent civilizations might self-destruct or avoid contact, but simulation theorists propose a far more unsettling fix. What if the silence isn't accidental, but by design? Picture a colossal computer running a universe-scale simulation. Processing power isn't infinite. Rendering trillions of alien worlds with fully conscious beings would demand astronomical resources. So what's the most efficient solution? Run only the parts being observed. In this scenario, Earth isn't just one planet among many, it's the main experiment. Distant galaxies could be mere backdrops, their stars and planets reduced to low-resolution placeholders. Any hypothetical aliens might exist as rudimentary code, never achieving true awareness unless activated by the simulators. It's like a video game where only the player's immediate surroundings are fully rendered. Everything else is fog and static. Critics call this cosmic narcissism. Why assume we're the special ones? Yet the paradox persists. Even our most powerful telescopes find no signs of Dyson spheres swallowing starlight or fleet signatures warping spacetime. Either we're catastrophically early or tragically alone, or the simulation hypothesis offers a third option, isolation by architecture. Perhaps the greatest irony is this: the very silence that makes the universe feel empty might be the loudest clue we're living in someone else's experiment. After all, if you were building a virtual universe, wouldn't you focus the processing power where it matters most? For all our advances in neuroscience, there's still a gaping hole in our understanding, one that glows like an exit sign in the dark theater of the mind. We've mapped neurons, traced neurotransmitters, even replicated brain circuits in silicon, but no one can explain why flickering synapses should feel like anything at all. Why does the wetware of your brain conjure the warmth of sunlight, the sting of regret, or the dizzying blue of a summer sky? Consciousness remains the last great unsolved mystery, and it might just be the key to unlocking reality's true nature. Think of your brain as the most advanced processor ever built, a 3-pound supercomputer running on 86 billion neurons. But here's the twist: it's not the hardware that's mysterious. It's the software. If consciousness is simply an emergent property of neural activity, why can't we replicate it in a lab? Why does stitching together artificial neurons give us chatbots, but not a single glimmer of inner life? Simulation theorists propose a radical answer because consciousness isn't produced by the brain. It's hosted by it, like a streaming service running on a device. This idea flips everything on its head. Near-death experiences, those vivid reports of tunnels of light floating above one's body, even conversations with deceased relatives suddenly take on eerie new meaning. Instead of hallucinations, could these be moments when the connection briefly lags, like a VR headset freezing before re-establishing its link to the server? The mind might momentarily dip into raw processing space before rebooting. Patients who have flatlined and returned often describe sensations of vast databases, infinite libraries, or even source code bleeding through. One man revived after 7 minutes of no pulse swore he'd seen reality's underlying grid, calling it the scaffolding behind everything. Of course, materialists argue consciousness is just an evolutionary accident, a byproduct of complex information integration. But then why does it feel so irreducible? You can't describe the taste of chocolate to someone who's never had it, no matter how many molecules you analyze. That stubborn subjectivity, what philosophers call qualia, hints at something deeper. If reality is a simulation, consciousness might be the user interface, the only way the program interacts with itself. Whether you believe the mind is a cosmic fluke or coded inevitability, one truth remains: we're all trapped inside our own awareness, unable to peek behind the curtain. And that leaves us with a humbling thought. If consciousness is software whose the one-hitting play, light zips through the vacuum of space at precisely 299,792,458 meters per second, not a fraction faster, not a hair slower. For over a century, we've treated this cosmic speed limit as an unshakable law of nature. But what if it's not a law at all? What if it's a safety feature? Imagine a computer struggling to run a sprawling open-world game. To keep the system from melting down, the developers impose limits: how many characters can appear on screen, how far the render distance extends. Now scale that up to a universe-sized program. Allowing information to travel infinitely fast would demand infinite processing power, like a GPU trying to render every atom in real time. The speed of light, then, might be the ultimate failsafe, a built-in bottleneck to keep the simulation stable. Even Einstein's relativity starts to look suspicious under this lens. The faster you move toward light speed, the more time slows down for you, a phenomenon called time dilation. Astronauts on the International Space Station age microseconds less than people on Earth because they're hurtling at nearly 8 kilometers per second. Simulation theorists see this as eerily similar to latency in an overwhelmed server. When the system's taxed, it prioritizes certain processes by slowing others down. Critics argue light speed is just a fundamental constant, no different than the charge of an electron. But here's the catch: in a simulated reality, everything would appear as fundamental constants to its inhabitants. The real question isn't whether the speed of light is arbitrary, it's why this specific number, too fast, and the cosmos would spiral into chaos. Too slow, and complex structures like stars and brains might never form. It's just right, like a dial carefully tuned to balance stability with possibility. Whether you see light's limit as physics or programming, one truth remains: in a universe where nothing outruns a photon, we're all playing by rules we didn't write. And that raises the spine-tingling possibility that those rules were coded by something else. Ever glance at the clock exactly at 11:11? For days in a row, or bump into someone you were just thinking about halfway across town? Carl Jung called these moments synchronicities, meaningful coincidences that seem to defy pure chance. He believed they revealed hidden threads connecting our inner lives to the outer world. But simulation theorists propose something even more intriguing. What if these aren't cosmic winks but debug alerts from the program itself? Consider how video games hide Easter eggs, tiny, deliberate surprises meant for attentive players. A recurring number sequence, an object out of place, a character repeating a cryptic phrase. In a simulated reality, synchronicities could serve a similar purpose, breadcrumbs left by the architects, nudging us to question the nature of our world. When hundreds report seeing the same angel numbers like 333 or 1212 on receipts, license plates, and digital clocks, it starts to feel less like randomness and more like a pattern. Skeptics argue our brains are wired to spot connections, even when none exist, a trick of the mind called apophenia, yet some synchronicities carry eerie precision. Take the case of author Anthony Peake, who dreamed of a plane crash in vivid detail only to witness the exact scene play out on the news days later. Or instances where two researchers on opposite sides of the globe publish identical breakthroughs simultaneously down to the same diagrams. Jung saw these as proof of a collective unconscious, but in a digital universe they might be evidence of shared data packets, glitches where the simulation briefly syncs two threads. Whether you see synchronicities as spiritual whispers or system notifications, their effect is undeniable. They fracture the illusion of a purely mechanical world. The next time reality serves up an uncanny coincidence, ask yourself, is the universe trying to tell you something, or is someone debugging the code? This section introduces a fresh angle while maintaining the script's exploratory tone, avoids cliches, and balances scientific skepticism with speculative intrigue. It flows naturally from prior segments like Déjà Vu and UFOs by examining another glitch category, deepening the simulation argument without repetition. Let me know if you'd like any refinements. At the heart of every galaxy lurks a cosmic paradox, an infinite more where the laws of physics unravel. Black holes don't just bend space-time, they annihilate information itself, shredding stars into quantum spaghetti while erasing every trace of their original state. This isn't just destruction, it's a violation of quantum mechanics' sacred rule that information can never be lost. So why does the universe allow these gluttonous voids to break its own rules? Unless, of course, they're not bugs but features. Simulation theorists see black holes as potential garbage collectors for reality. Think of your computer's recycle bin. When files become redundant, they're not truly erased until the system overwrites that storage space. Black holes might serve a similar function, permanently deleting obsolete data to optimize the simulation's memory. Their event horizons could act like firewalls, marking the boundary beyond which the program stops rendering details. After all, why waste processing power on regions no observer can ever access? The math gets eerily suggestive. When matter crosses a black hole's threshold, it's compressed into a one-dimensional string of data, a transformation that mirrors how computers encode information. Even Hawking radiation, the faint glow these voids emit, behaves like thermal noise from a malfunctioning hard drive. And just as a full recycle bin slows your PC, a universe cluttered with deleted information might risk system crashes. Black holes could be the cosmic equivalent of hitting Control plus Alt plus Delete. Of course, physicists propose alternatives, like holographic theory, where swallowed information gets projected onto a black hole's surface like a cosmic QR code. But the simulation angle offers unsettling elegance. If reality runs on computational limits, these monstrous voids might be necessary maintenance tools, quietly tidying up the universe's code. After all, every system needs a way to clear its cache, and what's more efficient than a singularity that devours the evidence? Whether they're cosmic backdoors or just nature's strangest accidents, black holes force us to confront a chilling possibility. Somewhere beyond the event horizon, the universe might be running on fumes, and we're just the data it hasn't erased yet. Here's the next segment, crafted to flow naturally from previous sections while introducing fresh angles and maintaining momentum. 12th idea. Time dilation. When reality buffers Einstein shattered our intuition about time with a revelation as poetic as it is bizarre. Clocks don't tick at the same rate everywhere. Near a black hole's crushing gravity or aboard a speeding spacecraft, time literally crawls compared to Earth's reference frame. GPS satellites orbiting our planet have to correct for this daily. Their clocks run faster by microseconds because they're farther from Earth's gravitational pull. But what if this isn't just relativity at work? What if time dilation is the universe's way of managing its own processing load? Simulation theorists notice something uncanny here. In virtual worlds, resource-intensive tasks like rendering complex physics or vast landscapes slow down performance. A game engine might reduce frame rates or simplify calculations to prevent crashes. Now imagine reality facing the same constraints. Near a black hole where space-time warps beyond recognition, the simulation might throttle time to handle the extreme computations required. High-speed travel could strain the system too, forcing it to prioritize certain processes by slowing others, exactly like lag in an overloaded server. Even stranger, quantum experiments show that observation itself affects how systems evolve. In the famous delayed choice quantum eraser, particles seem to decide their past behavior based on future measurements, as if reality is retroactively optimizing its own rendering. Time dilation might be part of this optimization, a cosmic compromise to keep the simulation running smoothly. Critics argue this is just how space-time behaves under extreme conditions, no programmer required. But the parallels are hard to ignore. If you were building a universe-sized simulation, wouldn't you impose speed limits to prevent system crashes? Whether it's physics or programming, one thing's clear: time isn't the steady river we perceive. It's a flexible fabric, and its wrinkles might be hiding the seams of reality itself. This segment opens with a vivid example. GPS satellites, to ground the abstract concept, introduces simulation theory as a fresh lens without rehashing prior points, balances hard science, quantum eraser with speculative intrigue, avoids repetitive phrasing, and closes with a thought-provoking twist. Let me know if you'd like any tweaks to tone or pacing. Picture a cosmic coin toss with 3 possible outcomes, and no matter how it lands, the result reshapes everything we think we know. Philosopher Nick Bostrom didn't just ask whether we could be living in a simulation. He framed it as a brutal trilemma, a trio of possibilities where at least one must be true. First, advanced civilizations inevitably self-destruct before achieving simulation technology. Second, they reach that pinnacle but opt not to create simulated worlds. Or third, the spine-tingling option: we're almost certainly living inside someone else's digital experiment right now. Bostrom's argument hinges on cold, hard statistics. If even one civilization ever cracks the code to simulate conscious minds, they could generate trillions of virtual beings with negligible effort. Over cosmic time, simulated minds would outnumber original ones by billions to 1. So unless you believe interstellar societies always collapse or universally reject simulation ethics, the math points to an unsettling conclusion. You're far more likely to be a data point in someone else's universe than a biological fluke in the real one. But here's where the trilemma bites back. Skeptics counter that Bostrom's logic assumes future civilizations would want to simulate ancestors, or that consciousness can even be digitized. Others suggest a fourth option. Perhaps simulations are inherently limited, incapable of spawning new simulations within themselves without infinite processing power. Like a snake eating its own tail, the chain might collapse under its own weight. Yet the trilemma lingers because it forces us to confront an uncomfortable truth: our odds aren't great. Either humanity's destiny is annihilation, asceticism, or artificiality. And if the third option holds, those glitches in reality we've been exploring aren't quirks. They're the cracks in a facade we were never meant to notice. So the next time your phone autocorrects eerily well or déjà vu hits, ask yourself, am I the exception or just another line of code in an ancient ancestor's cosmic experiment? 14th idea: Virtual particles, the universe's silent workforce, step outside on a clear night, and space seems like the emptiest thing imaginable, a void so still it feels frozen. But down at the quantum level, that nothingness is a seething hive of activity. Particles flash into existence for fractions of a second, borrowing energy from nowhere before vanishing again. Scientists call this quantum foam, and it's not some rare phenomenon. It's happening everywhere all the time, in the gaps between stars, in the air you breathe, even in the seemingly dead space between your fingertips and your phone screen. At first glance, this looks like cosmic wastefulness. Why would nature spend energy on particles that blink out almost instantly? But simulation theorists hear alarm bells ringing because this mirrors exactly how computers handle background tasks. Your phone runs processes you never see, checking for updates, indexing files, clearing cache. They're invisible, but without them, the system would freeze. Quantum foam could be reality's version of those silent maintenance cycles, tiny bursts of computation keeping the universe's code humming smoothly behind the scenes. Here's where it gets trippy. These virtual particles aren't just theoretical. They leave claw marks on reality we can measure. The Casimir effect proves it. Place two metal plates unfathomably close together in a vacuum, and they're inexplicably pushed together. Why? Because the space between the plates is too narrow for certain virtual particles to form, while outside they swarm freely. The result, a literal force born from nothing. It's like discovering your computer's fan spins faster when hidden programs run proof the system is working, even when you're not touching the keyboard. Critics argue this is just quantum field theory in action, no simulation required. Yet the efficiency is uncanny. A universe that constantly refreshes itself at the smallest scales, using particles that exist just long enough to stabilize the framework, looks less like chaos and more like optimized code. After all, if you were designing a reality engine, wouldn't you build in fail-safes to prevent crashes? Whether it's physics or programming, one thing's certain: the void isn't empty. It's busy, and that might be the only reason anything exists at all. 15th idea. The observer effect. Reality responds to your gaze. A candle flickers in a dark room. But here's the unsettling twist. Until you turn to look, the flame might not even be there. This isn't metaphysics, it's quantum mechanics at its most disorienting. At the tiniest scales, particles don't have definite properties until they're measured. An electron isn't here or there. It's a haze of probabilities, a ghostly potential that snaps into focus only under scrutiny. Physicists call it the observer effect, and it's as if the universe is playing an elaborate game of peekaboo with itself. Video game designers use a similar trick called procedural generation. Vast open worlds, think of sprawling fantasy realms or alien planets, aren't stored in full detail. Instead, the game renders only what the player sees, saving memory by leaving distant mountains as vague silhouettes until approached. If reality operates the same way, the observer effect could be evidence of cosmic optimization. Why waste resources calculating the position of every atom in a star a billion light-years away when no one's checking? Laboratory tests back this up. In the quantum double-slit experiment, particles act like waves when unobserved, creating interference patterns. But the instant scientists set up detectors to track which path they take, the particles choose a single trajectory, as if embarrassed to be caught mid-glitch. Renowned physicist John Wheeler took this further with his delayed choice variant, showing particles could retroactively decide their behavior after being measured, like a game character changing its costume based on when the player glances back. Critics argue this is just how quantum systems behave, with no conscious observer required. A falling tree does make sound even if no one hears it, because the air molecules vibrate regardless. But quantum theory insists otherwise. At the fundamental level, reality seems to require interaction to crystallize. Whether it's a quirk of physics or a feature of simulation architecture, one implication is inescapable: the universe isn't a static stage. It's a dynamic performance, and we're not just the audience, we're part of the script. 16th idea: simulated ancestors. Are we living in someone's past? History books let us study the Roman Empire or ancient civilizations, but what if future societies take it a step further? Instead of reading about their ancestors, they might recreate them down to every heartbeat, every whispered thought, every crossroads decision. This isn't just speculation, it's a logical extension of why we simulate things today. Scientists model climate patterns, economists run market forecasts, and video games let us relive historical battles. If an advanced civilization wanted to understand its origins with perfect accuracy, why wouldn't it build a full-scale simulation of its own past? And that raises a haunting possibility. What if we're not the pioneers of reality, but the reenactment? Every moment you've lived, the triumphs, the regrets, even the mundane choices like what you ate for breakfast could be data points in some future historian's research. Imagine a scholar 1,000,000 years from now, analyzing our era like we study the Bronze Age, watching your life unfold as a case study in how pre-technological humans navigated love, conflict, or curiosity. The eerie part: we already do this on a smaller scale. Archaeologists painstakingly reconstruct ancient tools. Psychologists simulate decision-making in lab experiments. Now extrapolate that to a civilization with godlike computing power. They wouldn't just read about the Industrial Revolution, they'd reboot it, tweaking variables to see how outcomes change. In this scenario, our present might be their antiquity, preserved in hyper-realistic detail like a cosmic period drama. Of course, skeptics argue that simulating conscious beings would raise impossible ethical questions. Why create ancestors who suffer, doubt, or grieve just to satisfy academic curiosity? Unless, of course, they see us as no more real than characters in a historical video game. Or perhaps they've built safeguards, digital veils, preventing us from realizing we're simulations to avoid skewing the results. Whether you find this idea humbling or horrifying, one thing's undeniable. If we are someone's history project, it means every choice you make right now matters in ways you can't imagine. Not just to you, but to beings so far ahead in time, they've turned our struggles into their classroom. So here's a question worth sitting with. If you were a simulated ancestor, would you want to know, or is the illusion part of the experiment? 17th idea: the holographic principle, a universe painted on the walls of reality. Close your eyes and picture the world around you. The depth of a canyon, the curve of a face, the way shadows stretch across a room. It all feels undeniably three-dimensional. But what if that richness is just an elaborate magic trick? Some physicists argue that everything we perceive, every galaxy, every atom, even you, might actually be a two-dimensional projection, painted onto the distant edges of the cosmos like a cosmic cinema screen. This isn't science fiction. It's the holographic principle, a radical idea born from the math of black holes. When matter gets sucked into a singularity, physicists found that all its information isn't lost, it's smeared across the black hole's event horizon like ink on a balloon. Stretch this logic to the universe itself, and suddenly reality looks like a hologram, a flat surface encoding all the data needed to render a 3D illusion. Your morning coffee, the mountains outside your window, even the feeling of wind on your skin, could just be shadows cast by a deeper, flatter reality. Think of your favorite open-world video game. The forests, cities, and oceans aren't stored as full 3D landscapes, they're generated on the fly from lines of flat, two-dimensional code. The holographic principle suggests our universe might work the same way, with depth as a user-friendly interface rather than fundamental truth, even stranger. This could solve one of physics' biggest headaches. How to unite quantum mechanics, the rules of the tiny, with gravity, the force shaping the cosmos. If gravity is just a side effect of information vibrating on a 2D surface, suddenly the math clicks into place. Skeptics counter that we've no direct proof the universe operates this way yet. But experiments like holometer devices are already hunting for pixelation in space-time, searching for the telltale fuzziness you'd expect if reality were fundamentally flat. Meanwhile, simulation theorists see eerie parallels. A simulated world wouldn't need true 3D rendering, just enough data to trick its inhabitants into believing it's there. Whether you imagine the cosmos as a hologram, a simulation, or something stranger, one unsettling truth remains. The richness of your reality might be thinner than a whisper, an exquisitely crafted illusion flickering on the walls of something far beyond our perception. And if that's the case, who or what is holding the projector? 18th idea. Escaping the simulation. Is it possible? Let's say the unthinkable is true. You're living in an advanced civilization's cosmic simulation. The walls of reality are just code, the stars are pixels, and your thoughts might be algorithms running on some unfathomable supercomputer. Now comes the real curveball. Could you break out? The idea isn't as far-fetched as it sounds. Hackers manipulate systems every day, exploiting glitches or reverse engineering software. If our universe operates on similar rules, why couldn't we find its backdoor? Some theorists point to quantum anomalies as potential weak points, areas where the program shows strain. Entangled particles communicating instantly across galaxies, particles popping in and out of existence, even black holes erasing information. These might not just be quirks, but vulnerabilities. Imagine discovering a cosmic control plus alt plus del combo, a sequence that forces the simulation to reveal its source code. But here's the darker twist. What if the architects anticipate rebellion? Think of a game developer banning players who exploit bugs. Would a civilization running a universe tolerate rogue simulations meddling with their creation? Some argue that any attempt to escape might trigger a fail-safe, a reboot, a shutdown, or worse. Philosopher Preston Green warns that prying too deep could be like a character in the Matrix unplugging themselves only to find their world vanishing entirely. Then there's the existential gamble. Even if you could exit, what waits outside? The real world might be a barren wasteland, a post-apocalyptic hellscape, or a lab where simulated beings are disposable test subjects. Would you risk trading your familiar illusion for a truth that shatters all meaning? Perhaps the most haunting question isn't whether we can escape, but whether we should. After all, if this simulation is all we've ever known, with its sunsets, laughter, and love, does it matter if it's not base reality? Or is the yearning to break free the ultimate proof that we're more than lines of code? One thing's certain, the urge to peek behind the curtain isn't just curiosity. It's the human spirit refusing to accept any walls, even the ones we can't see. Final thoughts. What if it's all real? After this whirlwind journey through black holes, quantum glitches, and cosmic déjà vu, one thing's undeniable: the universe is stranger than we ever imagined. Whether you're sold on the simulation theory or still clinging to the comfort of base reality, these ideas do something remarkable. They crack open the door to questions we've been too afraid to ask. What is real? Who or what gets to decide? And if the answer is none of it, then why does it feel so vivid, so urgent, so alive? Maybe that's the most fascinating twist of all. Even if our world is a fabrication, the experiences we have, the ache of loss, the thrill of discovery, the quiet awe of a starry night, aren't diminished. They're amplified because whether coded or cosmic, these moments are ours. They shape us, define us, and in the end, that might be the only truth that matters. So where does that leave us? Not as passive data points, but as witnesses to a mystery too grand to ignore. Every unexplained coincidence, every law of physics that feels just a little too perfect, invites us to look closer, dig deeper, and stay relentlessly curious. The simulation hypothesis isn't just a theory, it's a mirror, reflecting back our deepest hopes and fears about existence itself. Now it's your turn. Do you see these clues as proof, coincidence, or something in between? Drop your thoughts below. We're all explorers here, piecing together the puzzle one wild idea at a time. And if you're hungry for more reality-bending deep dives, hit that subscribe button. The universe, simulated or not, has plenty more secrets to share. Until then, stay skeptical, stay wondering, and above all, keep daring to ask what